Now, the name trigonometry literally means the study of triangles, and the right triangle is the heart of trigonometry. It forms the basis for the study. The shape of a right triangle is completely determined by its angle measures. Once we know the measures of the angles of a right triangle, and one of them is always going to be 90 degrees, we can determine the lengths of its sides. We use the three trigonometric ratios named sine, cosine, and tangent to help us do this. So this particular problem says determine the values of the trigonometric ratios for angle A and angle B of the right triangle. And of course we have this graphic here of this right triangle, and it's labeled angle A, B, and C. And a couple of things I want to point out is we're looking for the ratios. A trigonometric ratio, a ratio is written as one value over another value. Keep that in mind. So we're looking for the ratios related to angle A and angle B. A couple other things we want to point out is if this is angle A, the side that's across from it, that's way over here, this is labeled as side A, and that's just a lowercase letter a. For this particular triangle, it just happens to be equal to 7 units. Here's angle B. The side opposite B is this one over here, right across from it. So we'll label this one leg B, and that's, of course, a lowercase b. And this one just happens to be 24 units. And the angle right across from, the side length right across from angle C, that's our hypotenuse. That's right across here. And we don't have any angle measure related to that, or side length related to that one. The side adjacent to A, that's the one right next to it. Adjacent means next to it. So the one right next to A, so that the side that's adjacent to A is also the opposite of B. And the side that's adjacent to angle B, that's side A, that's also known as the opposite of A. So there's all kinds of stuff going on here. But the trigonometric ratios say sine of A, and that's how it's pronounced. It's abbreviated as SIN, but it's pronounced as sine. That means that the sine of A, that's going to be equal to the opposite side of angle A. That's over here. So that's side A over the hypotenuse, and that's C. The cosine, and that's how that's pronounced. It's abbreviated as COS, but it's pronounced cosine. The cosine of angle A, that's equal to the adjacent side, that's B, over the hypotenuse. And then the tangent of A, and that's how it's pronounced. It's just abbreviated TAN, but it's pronounced tangent. That is the opposite side, that's A, over the adjacent side. So that's going to be A over B. Then we're going to find the trigonometric ratios for angle B. We'll do the same thing. So we have the sine of angle B. That's going to be the opposite. That's going to be B, side B, over the hypotenuse. The cosine of B, that's going to be the adjacent side. That's going to be A over the hypotenuse. And then the tangent of B, that's going to be its opposite over its adjacent side. It's going to be B over A. A couple other things to point out is that the sine of A, which has the ratio A over C, is the same as the cosine of B, which is also the ratio A over C. And consequently, the cosine of A, which has the ratio B over C, is the same as the sine of B, which has the same ratio B over C. And notice that the tangent of A has the ratio A over B. That's the inverse of the tangent of B, which is B over A. So then what are the trigonometric ratios for angles A and angle B? And there are no trigonometric ratios for angle C, because angle C is known as the right angle, and it's always going to have the opposite of the hypotenuse. So this, A, which is 7, over the hypotenuse. Now the hypotenuse we don't know. But we can use the Pythagorean Theorem to help solve for it, right? So that's A squared plus B squared. That's equal to C squared. And of course, if we use some algebra, we solve for C. We can write it as C. It's going to be equal to the square root of A squared plus B squared. A, that's 7 squared, plus B, that's 24 squared. 7 squared, that's 49. 24 squared, that's 576. 49 plus 576, that's 625, and the square root of 625 is 25. Now don't forget, just like we did in the last problem, you could just go ahead, once you know what the setup is to determine what this measure is, you can just go ahead and plug it into your calculator all at once, and you should come up with 25. So our hypotenuse here is 25. So then the sine of A is equal to A over C, which is going to be 7 over 25. Then we do that for each one. The cosine of A, that's going to be 24. That's B over the hypotenuse. So that's going to be 24 over 25. And then the tangent of A, that's going to be the opposite side over the adjacent side. That's going to be 7 over 24. And we'll do the same for angle B. So the sine of angle B, that's going to be 24 over 25. Cosine of B, that's going to be 7 over 25. And the tangent of B, that's going to be 24 over A, which is 7. And of course, you could see that the sine of A is 7/25. That's the same as the cosine of B. That's also 7/25. The cosine of A, that's 24/25. That's the same as the sine of B, which is 24/25. And the tangent of A is 7/24. That's the inverse of the tangent of B, which is 24/7. But we found all the ratios.